Hello, this is Keith Kreischer, the Executive Director of the IoT M2M Council, or IMC. And it's my pleasure to welcome you all to this webinar on iSIM and IoT, brought to you by the IMC. I certainly hope everyone joining us today is staying safe and well in these interesting times. The topic for today's panel discussion is iSIM and low power, actually, and today's panel will be moderated by my good friend, Matt Hatton, founder and principal at Transforma Insights, one of the best known analyst firms in the IoT sector. And the discussion will feature Flow Live, Deutsche Telekom, and Thales for the next hour or so. I'll hand off to Matt in just a minute, but first, a couple of housekeeping items. Before we begin, I wanted to cover a few things. This webcast is being streamed through your computer, so there is no dial-in number. For the best audio quality, please make sure your computer speakers or headset are turned on and the volume is up so you can hear the presenters. An on-demand version of this webcast will be made available later today and can be accessed using the same audience link sent to you earlier. If you have any questions during the webcast, you can submit them through the Q&A box on the right side of your screen. The presenters may answer questions at the end of each presentation or discussion, but please feel free to ask questions at any time during today's panel. Any unanswered questions will be responded to either at the end of the session or offline. We will have a record of your registration. We'll be able to match that with your question, and our panelists will get back to you. For those of you that do not know the IMC, perhaps just a quick word of introduction about our organization would be a good idea. The IMC is the largest trade organization dedicated to the global IoT sector. Its membership is comprised of 28,000 rank and file adopter members who are individual enterprise users, product makers, and OEMs and apps developers that deploy IoT solutions in the field. The IMC's board of governors includes 35 of the most influential IoT technology companies that provide solutions in the form of hardware, software, and connectivity. Some of them are with us here today for the panel. We encourage any attending today to check out our website, which is iotm2mcouncil.org. On that website, you'll find more information about the IMC's newest initiative, just announced this year, and that is a joint task force on IoT security, which we formed with the Global Certification Forum. There's lots going on in the area of IoT security right now, but what makes this initiative unique is that it covers not just devices, but also IoT networks and cloud app platforms. So please take a look for that on the website. Moving on to today's session, the mission of the IMC is to accelerate the adoption of IoT technology for the public good. And we look at today's session on iSIM and low power applications as exactly in keeping with that mission. Now it's my pleasure to introduce Matt Hatton from Transforma Insights. Matthew, good afternoon. Can you hear me, Matt?
How's that?
There he is.
Yeah.
He's there.
I fell at the first hurdle, Keith, with doing a webinar.
There you go. There you go. Welcome, and take us away, please.
Thank you very much, Keith. Hello, I should introduce myself. Keith did a brief intro to us, but I'm Matt Hatton. I'm one of the founders at Transforma Insights. One of the things that we do is we look at the key trends in IoT. For instance, we put out a set of what we describe as transition topics at the end of last year for key things that we think are going to be interesting in 2025, and we do that every year. And this year we included eSIM. Now, that's sort of adjacently related to the topic of iSIM, but iSIM is quite an interesting one because it feels like a subject that's kind of been hanging around for about a decade. This idea of the physical SIM disappearing and being replaced with something software based. So it's had a bit of a long gestation, but maybe it's time for, as this session is described, for the iSIM to take over. I guess that's what we'll be discussing today. In fact, I know that's what we'll be discussing today. So in terms of the structure for today, I have three speakers who will be able to introduce themselves and introduce their company and their initial thoughts on this area of iSIM. And then we'll get into a a set of structured discussion topics where I'll cover off on what I think are the key themes relating to iSIM and things we should all be aware of. And then we'll have some time at the end for your questions. So please do drop them into the Q&A box and we will get to those at the end. So I should welcome my first speaker, who is Stefan Keglas, who is the Embedded Solutions Marketing Director at Thales. So Stefan, over to you first.
Yeah, thank you, Matt. And thank you for having me in this panel. So as you said, I'm Stefan. I'm in charge of marketing at Thales. So I work for the cyber security and digital identity business at Thales. Thales is a big group. Just to quickly introduce what we do. So we are focused on the three pillars. Three main core business segments. So you have aerospace and space, defense and security, and cybersecurity and digital identity. And within this organization, we can say IoT is a major market for us. We do serve mobile network operators, OEMs, and service providers with our products, their hardware products, and also connectivity and security services. So we have vast experience in that field. We are leading the leader in eSIM for IoT, especially in the industrial and automotive sectors. We shipped hundreds of millions of units of hardware root of trust, be they SIM cards, eSIMs, embedded secure elements, etc. And we have all the solutions to remotely manage these eSIMs. Certainly come back to that later. And in terms of security, we are very proud to be part of the top five cybersecurity firms in the world after acquiring the company Imperva last year. So that's it for the Thales introduction. I'd like to give you a little bit of insights about what we think about integrated SIM. This is actually, as you said, Matt, this is something that started quite some years ago already. So we actually started on integrated SIM with a consumer product in partnership with Qualcomm on their Snapdragon chipset. And our goal was to come with a product to demonstrate that we can equip a smartphone, for instance, with an eSIM that can achieve the same level of functionality, but more importantly, the same level of security in a large chipset like the Snapdragon, as with a classic eSIM running on a dedicated secure chip. So for us, the story started like this. I think you said 10 years ago also. Yeah, that's approximately the time it takes indeed. In the context of IoT, for us, the iSIM, the integrated SIM, means essentially an integrated EUICC, and that supports the remote SIM provisioning technology named FGP32, but because this has become a really must these days. And therefore, we consider the integrated SIM to be essentially a new form factor, which is tailored for diverse applications. We will come back to that later. And the vision for us is that the iSIM is bringing benefits for our device makers in terms of streamlined design, but also when it comes to operations, when you have energy efficiency, which is a major topic for discussion today, and high versatility. So to achieve this and to deliver the full benefits to the IoT ecosystem, the iSIM has to be scalable, has to be interoperable and secure. So we continue working with our long-standing partner Qualcomm on iSIM for IoT. So you see here the name of the product we are using together to bring this integrated SIM HGP32 capable to the market, which is the Qualcomm E41 4G modem RF Cat1 bis chipset actually. We also work with a French firm, Sequence, on the lower power solutions, so with Cat-M and narrowband IoT chipsets that they provide on the market. So this being said, you will find in the handout that we provide a larger description of what we do. Actually, integrated SIM for us is fully part of our approach to IoT and for portfolio of solutions that we have split across three pillars: build, run, protect. to enable secure connectivity and lifecycle management of this secure connectivity in devices, in IoT devices, all along their life cycle. So from the design, the manufacturing, the operations. So if you want to have more information, you will have the handouts, and you have a few links you can click on to know more about what we do. So that is in a nutshell where we stand today on the iSIM for IoT.
Excellent. Thank you, Stefan. And now I'd like to welcome Stefan Kalina, who is from Deutsche Telekom. Stefan, over to you. You will need to unmute your microphone. I think it automatically mutes, which is perhaps a little annoying.
All right, so that's
there we go.
Better.
Welcome.
Welcome, everybody, to the headquarters of Deutsche Telekom, Bonn, Germany. I don't think I have to say a lot about Deutsche Telekom. We are a network operator, not less and not more. We have networks in Europe and very successfully also in the US. And that means we can go right down to the topic. So the iSIM takes over. When Deutsche Telekom, when we talk about iSIM, then we talk about NewSIM, because NewSIM is our special version, our solution for an iSIM. How did we get to that? It's been a couple of years ago, like 5 years ago already, and there was a customer asking, actually, why isn't the processor, which is in the module, in the radio module, or the application processor, which is also somewhere in the device, why isn't that capable of just doing the SIM functionality just like that, without any additional other component necessary? That would take away a pain point, would take away a lot of stuff around logistics and things always not being at the place where they need to be, these kind of things. And we said, hey, actually, it's a great idea, but this is not existing. And at that time, 5 years ago, it wasn't on the market. So there were no solutions at all on the market. And that started us to think about that. And yeah, we decided to do it ourselves, not alone, but together with partners, and try it out. And today we are looking into a mature product, which is making a lot of sense for us and for our customers, gives us a unique selling point, a differentiator. Yeah, and it's just doing what it was supposed to be. And along the journey, we were able to make a lot of experience, a lot of learnings, and I'm happy that I'm able to share a couple of them today with you guys. All right, I don't want to talk too much about NewSIM. This is not a sales pitch, so let's have a look at the subject from a more general perspective. Yeah, I call it an evolution of SIM cards. Everybody knows what has been going on across the last 20 years or so. The SIMs became smaller and smaller. There was the plug-in, the micro, the nano, the solderable component. And by the way, there is relatively new. There are 2 additional MFF formats, very small, 2 by 2 millimeters and 3 by 3 millimeters, just out of standardization. However, this is not the end of the story. So we believe that the ultimate solution, at least for the moment, who knows what's going to come next, is there is no SIM. But of course, it doesn't mean that there is no SIM functionality. It's just that the component, the separate component of a SIM card, is not there. So how does that look like? What we see here is a picture of what we call a development board. So every radio module manufacturer has these boards to offer, and this is something to try software out, to experiment with that component, and to play around with it, basically. And as you can see here, the biggest component on that board is the module, the radio module, and the second biggest component is the SIM slot. This is one of the first implementations for NewSIM. So how can we show an integrated SIM? Yeah, we put a little piece of paper into the SIM slot to indicate, hey, there is no SIM in that slot. But where is the SIM? Yeah, it's inside the module, and even deeper, it's inside the chipset. By the way, this is a Quectel BG95 module with a Qualcomm chipset inside. On the chipset, there is new SIM running. Looking at the use cases, we have not been able to determine that there is a specific single use case very likely to use integrated SIM or not. We see interest for this technology across the board. And on this slide, a few examples, real examples, by the way, from our business, starting with the smart lock that's running on harvested energy from a solar panel. We have those smart labels. We have the pharma smart label, a very special device, by the way. And on the very right, that's a very interesting use case, again, about energy harvesting, done together with a quite famous sports goods manufacturer. Yeah, and that was an R&D topic. The shoes were supposed to generate their own energy from the movement of the shoes of the runner, in order for the runner to establish a connection and to send out emergency calls or whatever is necessary. However, this has just been R&D. It's not yet mature enough. It's not yet an off-the-shelf product. You have to run quite a lot in order to send a few messages. However, an integrated SIM seemed to be the best suitable solution. So what we see is that wherever it's about power efficiency or robustness or these kind of things, then an iSIM is the best possible solution. Yeah, and what we also learned across the journey, it's not always such a matter of price. Of course, price is always important, but sometimes these characteristics, these requirements are even more important. And then it's a very clear way forward to use an integrated SIM if one is available for that particular module that the customer is using. So much for now. I would like to hand back to Matt. Thank you.
Hang on, I have to remember to unmute myself. Thank you, Stefan. Now handing over to our third speaker for his initial comments. That's Nadav Doron from Flow Live. Nadav, over to you.
Yeah, thanks, Matt. And thanks, Stefan, for the excellent use cases. Very interesting. So I'm very happy to be here today and to talk with you about our offering regarding iSIM. My name is Nadav Doron. I'm leading the product management team for Flow Live. So for those of you who don't know Flow Live, though we are in the market for several years already, our mission is to connect all devices, all IoT devices to the network with unmatched coverage. We have the largest network in the world in terms of point of presence, high availability, great performance, security, and efficient support. So I'll tell you in a minute how do we do that, but what you can see here at the bottom is kind of some names, maybe not the most well-known names. Some of them are, some of them less. But we sell to all verticals. We sell to enterprises, to MNOs, to MVNOs, in many verticals. So we don't focus on one vertical. And this is what we want to show here. We have around 170 employees. Most of them are R&D. We have 4 large offices in the EU, in the UK, US, and Israel. So this is about us a bit. Our solution is comprised of 3 components. So we have a CMP, a connectivity management portal with real-time billing, managing the SIM, and managing the actual connectivity rates, etc. We provide these to our customers. We have our own mobile cores. We have around 40 mobile cores distributed around the world, with many point of presences as local breakouts or the actual cores. built of our own technology. And we have the SIMs. So for the SIMs, we have developed an applet, a multi-IMSI applet, and we were able to deploy this applet on different vendors' SIM. So for example, we have a partnership with Thales, and we have partnerships with others as well. And we deploy our applet, multi-IMSI applet, regardless of the type of the SIM. And this is where we are getting into the iSIM relevancy. Our product is, as I said, we have the three components: the connectivity management, the billing and rating, the core network, and RSP and SIM management. Some of this is done by us, and some of this is done by our partners to maintain the provisioning. But let's talk about the SIM. So, as I said, our applet can be deployed on any of the SIM form factors, as you've seen in former presentations: plastic SIM, whether it's UICC or EUICC, the MFF2, and now the iSIM. Our applet supports all of them, and we have customers with all of these form factors more and more. And one of the key advantages that we provide our customers is that we have single global SIM regardless of where they are in the world. So our connectivity, because of the multi-IMSI and the ability to change IMSIs according to logic, then we can support one SIM to be deployed regardless where you are in the world, where the device is in the world. And if it moves to different territories or there is a disconnection, then there is a way to switch IMSIs and switch providers to increase the global coverage. So this is our solution. And what I'm going to talk about later here today in the panel is about how we see this applet and the entire solution come into play with the different form factors, and specifically with the iSIM.
Okay, excellent. Thank you, Neda. And if I can welcome everybody back up on stage, you know, I think you all know what I mean. Okay, great stuff. Thank you all for the intros. I'm conscious there may well be some people who are joining this webinar who may not be as much experts on SIMs as you gentlemen are, and maybe a little bit confused by the terminology. So I think it's a useful thing to talk through there, because we've got iSIM, we've got eSIM, we've got soft SIM, we've got EUICC, we've got IEUICC. There's a whole bunch of terminology there. So can we unpick that a little bit? So Stefan Q, maybe I've got two Stefans, which is never the easiest thing for me as a moderator, but I'm going to go Stefan Q. Can you unpick that for us a little bit, and just as a sort of explanation for anybody who's relatively new to the space, or even those of us who have been in it for a while?
Yeah, sure. That's the challenge of the day with two Stefan in a panel. Yeah, indeed. SIM, I think everybody knows what a SIM is, because everybody is used to have a smartphone and insert this removable product made of a small chip with some contacts, plastic in a device. So indeed, when you hear iSIM on the market, it's still confusing because it can mean different things. So if we start from the very beginning, when the GSM networks were created, so the SIM has been created as the way to secure the access to the network, right? So it was a removable product. It still is, but it was available in a very big form factor, like your credit card, basically, and then decreased in size across the years. And Stefan shown a nice slides showing the evolution, indeed. So people are used to talk about SIM, and there's a technical term that is more used by the standardization expert, that is the UICC, which came when the standardization of 3G started, splitting the, if you wish, the secure platform, the smart card platform, from the authentication, network authentication application, which is the SIM. So this is when we started having these different acronyms. For the sake of simplicity, it's better to keep SIM in mind. And then later, when we started to, for instance, want to connect cars in Europe for emergency calling, for instance, we had some issues in terms of using a SIM in a slot, and so having a SIM soldered inside the device was better. But then you come with the problem of the SIM is just with one mobile network operator profile inside, so you can connect only to one network, and you cannot change. So you can roam, of course, you can go to other networks, but your home operator remains the same. So another technology was created, which is the eSIM, to enable the remote management of these profiles. And the other difference is that you can not only have one mobile network operator profile inside eSIM, like in a SIM, but you can have several. So you can add, remove, activate, deactivate, etc. And this eSIM was also dubbed as EUICC for embedded, right? Embedded UICC embedded in a device. And iSIM actually today refers to both. So some people say when I have an integrated SIM, they refer to, and I think Stefan will get to that, it's a SIM functionality that is integrated in a larger chipset. When a SIM is actually developed and hosted on a very dedicated secure microcontroller chip. For others, and I think it applies also to us, Thales, when we say iSIM, we also refer to an embedded SIM, an eSIM that is integrated in this chipset. So that is why it is confusing. It's I think our responsibility in the industry to clarify that. I think when you look at the evolution on the market, more and more people are talking about iSIM being like an eSIM that is remotely configurable, but it's not always the case, because it's true that it is not the sole solution that is needed on the market. You need both, actually. So we'll find maybe tomorrow or soon a way to clarify this. But iSIM can mean both today, and this is something we need to change. Yeah.
Okay, good stuff. And Stefan, Kate, can I turn to you? Anything to add to that? And particularly, I want to ask about new SIM, because obviously that's another variant again. You're still muted, or you're muted again. You should only have to do this once more, I think. There we go.
Sorry for that. That was a very, very comprehensive explanation, Stefan. So there's not a lot that I could add to that. I believe if you take this one thing home from today's session, that an iSIM is nothing but a general term for any kind of SIM integrated in a larger host component. And the term iSIM itself does not at all define any specific functionality, apart from it being a SIM. Of course, what a SIM is, everybody knows what a SIM does, what it has to do. And that's, of course, done by an iSIM. But if it's an eSIM, or if it's a multi-IMSI SIM type of thing, or if it's just a very simple SIM with only the minimum ingredients, this is totally unclear just by naming it iSIM. And some companies take this iSIM as a brand name, and they go and say, hey, we are offering iSIM. So the next question should always be, what is it? What does it do? So that's for sure a very important detail here in the discussion, to be clear about that. And Matt, you were asking for new SIM. Well, new SIM is exactly an iSIM, because it's an integrated SIM. So, but if you look deeper, then you are in the non-eSIM area. So new SIM does not pretend to be an eSIM, and it's not. It's on the other, more on the contrary. It's what we think is the simplest possible SIM. So it's all about simplicity. Bring network access to the device in a very, very simple manner with a digital process, and because this is what customers are asking for. Not everybody needs eSIM. eSIM is a complex and, of course, also expensive SIM variant. There are many good use cases for eSIM, but there's also a lot of cases where a standard, simple SIM does the full job.
Good stuff. I'm going to come back to you on that one in a moment, but I wanted to turn to Nadav, and I think I want to get to the main nub of the topic that we have at hand, and I'm sure both of the Stefans will want to contribute on this one. But Nadav, I'm going to come to you first. Advantages and disadvantages of iSIM. People talk about power efficiency, security. Those are advantages. Potential disadvantages maybe around cost or SKU management, integration, testing, that kind of thing.
Yep.
Can I get your perspectives on that pros and cons of iSIM versus other alternatives?
Sure. Thanks for the question. So, iSIM, at the essence, it has less components for the SIM component. So it means smaller BOM, bill of material. The manufacturing itself is more simpler, and of course, power savings. When the component itself are embedded within the larger device and are not part of the dedicated SIM, then there is less power loss and hence savings, and it's especially critical for battery sensitive verticals. Automotive has been has been mentioned here, but I think also asset tracking, with very small devices with battery that should last a year or two or even more. So in that case, the power consumption of the device and of the SIM is crucial. Hence, the power saving are most important here. You mentioned also security, which of course is part of it. Part of it is as well. The SIM is no longer on the plastic card, as I said, so it's bounded to the chipset. So there's less opportunities to hack into it, and it's more now at the software layer and less on the hardware layer. SIM itself is a very secured component. Now that it's part of the device, it becomes even more secured. So I think these are looking at the advantages, these are the main advantages that we see for iSIM, and that's what we hear also from our customers. Why do they want, or why do they choose iSIMs? But on the other hand, yes, there are several complexities here for the let's say the operational side of it. You need to be more aware of the different SKUs. So what's your inventory level? And there are ways also to overcome these with pre-manufacturing of specific configurations, etc. So also we have worked with our partners to manage some kind of a pre-integrated deployment, so that the lead time can be reduced. But the combination of the SIM, the actual SIM, the connectivity on top of it, the OS, the other modules needs to be managed, and this is kind of the trade-off from the other side.
Okay. Thank you. Stefan K, can I come to you on this one? Pros and cons of this. Power, I think, was one of the motivating factors for new SIM, right? In terms of reduced power consumption, just simplification of the device. Other thoughts on advantages, disadvantages of iSIM versus other form factors?
A very interesting aspect is also the digital provisioning process. We have customers actually asking only for this. They are simply tired of handling SIM cards, or they are starting a new device, starting a new whatever business, and they don't want to start handling SIM cards. And so, what is the solution? It's a digital process that comes together with an iSIM. An iSIM itself is, first of all, is a set of functionality integrated in the device. But there is not yet connectivity. There is not yet a subscription. That has to be added to the device through what we call a profile. A profile is a set of data related to an operator, basically the same data which exists on every SIM card. And only once this data is loaded onto the device with the integrated SIM, only then there is a subscription and there is connectivity. So, and this loading part and the way how these profiles are being generated and are being delivered and are being loaded to the device, this is what we call the SIM provisioning or iSIM provisioning part. Yes, and that's a digital process, obviously. We are not talking about any physical elements. We are talking about data to be sent, perhaps over the air, but more typical in an IoT use case, it's over the wire, it goes over the internet, it goes into the factory. And here we are at in-factory profile provisioning. And I guess we'll come to that later. But that is an aspect. Make it simpler for the customer, which must not be underestimated.
Okay, good stuff. And Stefan Q?
Yeah, I fully agree with what has been said. I just wanted to add that these manufacturing operations that are going to be adjusted to take the iSIM into account, it's a trade-off. So you exchange let's say you trade the handling of physical SIMs or eSIMs against digital profiles, plus this digital profile, they need to go into inside the device. So you need to adapt your manufacturing or production line to make it happen. So depending on the size of your business, the size of the volumes you are going to produce, it could be that for the smaller customers, the change in the manufacturing chain that is not worth the effort. Whereas for bigger volumes where you ship millions of devices, then you can invest in such a solution and then truly digitalize your supply chain. So I would say the benefit will depend also on the type of business you're conducting. What are the size of the typical batches you're producing, and where they are going also? Are they the same for the whole world, or are they dedicated to some customers in some regions?
Okay. So I was going to come on to the provisioning topic later, but we seem to be on it. So let's stick with this theme, because fundamentally the issue is that iSIM changes the way that you would provision connectivity onto the SIM card, right? So rather than plugging in a SIM card which has already got a profile preloaded, what you're doing is flashing profiles onto the devices during the manufacturing process, and that creates a whole new separate set of dynamics. I think. If I can stick with you, Stefan. How do you see that as changing the dynamics in the market and the way in which the connected devices are being built?
That's well. What is super important for an OEM is not to modify their factory in depth, meaning they really need a solution where they don't have to increase the security level of their factories. That's very critical. So that means you need to have a solution that takes care of these security aspects beforehand, and it's typically done by a collaboration between the chipset vendor and the iSIM vendor. This is where you need to collaborate to ease the life of your customers. So that means that in terms of dynamics, you need to have a closer collaboration between between chipsets and iSIM vendors to make it happen properly. Then, in terms of if you tell me we're considering an iSIM with a remote SIM provisioning capabilities, it's an eSIM that is integrated. Then afterwards, it doesn't change a lot in terms of dynamics, because once the device is manufactured, then you have exactly the same functionality as a device with an eSIM. So you can choose your and especially with the RGP32 technology, you can, like a consumer would do for the smartphone, you can choose the connectivity provider you want and have it downloaded on your device. So that's very easy. In the case you have I would say an integrated SIM which is not RSP capable, which is the equivalent of the good old traditional SIM card in terms of functionality, then it's important to figure out ahead of the deployment if all the actors are aligned, because you need the chipset players, you need the iSIM vendors, but you need also the telecom operator. So in the case of Deutsche Telekom, I think New SIM, they have the integrated solution, if I would say end-to-end, I would say. If you're considering other types of iSIM that are similar to New SIM, then you need to consider aligning all these players together, which is an effort you need to do on a project basis, because you don't have a standard or an interoperable standard you can rely on. You don't have the certification in terms of security assurance of the product. So that these dynamics change also at this stage because of this alignment you need to make. So here again, I think in terms of volumes, it makes sense if you sell a lot of these devices, because it takes time to align everybody.
If I add to that, Matt?
Please.
Yeah. So I think these are very, very valid points, and I think that one of the experience that we have seen in the field in the last year or so is that in order to overcome these challenges, yeah, you need to preload whatever you can, but then you can do the RSP, or you can use we have our own technology that does the same with different variances with the multi-IMSI selection. So you can download different IMSIs. You can change the right connectivity, and I agree that having all the components in one, having enterprises trying to arrange all the components from all the manufacturers in one place can be cumbersome. So we've come with an offering that does exactly that. And I think a great example for that was that recently we have started deploying a satellite-based IMSI on an iSIM. So it's a kind of a cool example of the two technologies coming together in one place.
Absolutely. And Stefan, I'm sure you'll have a perspective on this question of provisioning.
Yeah, we're looking at the IoT market, which actually is a very fragmented market. We don't have that many big players, but we have many very small players. And these customers, there are no two customers that are the same. They all have their different demands, their different agendas, their different products. So the best you can do is offer a very flexible way of provisioning. I already mentioned the in-factory provisioning. And indeed, Stefan, you are perfectly right. This only works with a certain volume. If the volumes are too low, then it doesn't make sense to do all the integration work that's necessary in the factory to install what we call the loading agent. That's a piece of software. But again, every production is different, and there is always an integration project necessary, which we can't do because it wouldn't scale for us, but the customer has to do that.
So it'd be relevant for consumer electronics or automakers, that sort of scale of organization, but maybe not if you're making or doing a
Yeah,
monitoring.
But how to handle the small ones? Then, of course, there are the distributors between the module manufacturers and the customers. And on distribution level, it also works quite well because it gives the distributors an added value to load the profiles on behalf of their downstream customers. And so the customers get the modules with the profiles already loaded. Or if the volumes are really big, then we might be able to convince the module manufacturer to do this job already on his level. So all the modules that come out of them are already completed with the connectivity. So all these different cases do exist, and they have to work side by side. Yeah. Different customers, different needs.
Does that mean that the module manufacturer effectively is likely to provide a bootstrap that is almost a neutral bootstrap that then allows the buyer to localize onto whichever network they prefer, or is there some sort of value to the real estate of being the manufacturer of that iSIM that you effectively control or have some greater channel to market for selling your connectivity as well? How do you see that working?
Well, the more higher in the distribution tree, in the value chain, we can bring in our connectivity, the better for us. However, it doesn't work that way. So at least we are not able to convince a major module manufacturer to make a certain segment of their devices all with Deutsche Telekom connectivity. That won't work. That won't work. It may work for very large customers, and large customers here, I'm talking hundreds of thousands, if not millions of devices. In that case, module manufacturers are able to do that. They hate customer-specific SKUs, but if the volume is big enough, that hate may turn into, I don't know, love maybe. So it can work that way. Yeah, and for the rest, then there's the distributor. The distributor is capable of handling customer-specific SKUs. That's what they're doing all the time. They are looking for added value anyway. So it gives them a nice added value to do the profile loading on behalf of their customers. Or we do it at the customer, but then the customer is in control, has to take care about the integration, has to spend some upfront investment. So that, again, works only for larger volumes. But if it is everything is installed, then this is working. This is a great solution, which is close to the current, to the old plastic SIM solution, where also the customer is inserting SIM cards and is in control. So all these different options exist side by side, and there is demand for each of them.
Can I throw one other, maybe slightly contentious question, and I'll let whoever wants to have a go at it answer. The big focus here, or the title of the session, is about reducing power consumption, which is great. That's a very valid requirement for iSIM. But the fact that you'll probably have to do at least one, but probably multiple in-field localization actions will potentially burn through quite a lot of the battery of any given IoT device. So there is a question of the trade-off between those two elements, isn't there? Or is there? Or do you is that the reason why you do in-factory provisioning?
Yeah, absolutely. I think you're totally right. The benefit of having this bootstrap connectivity is really to make your life easier at the factory, because you get your just one iSIM configuration. It's easy to manage, and then on the field you will decide. And sometimes you need to decide when the device is on the field, because it really depends on the actual location. Maybe you just know the country where the device is shipped at the factory level just before the shipments take place. And you need to, because of coverage consideration, for instance, you need to make sure that this device that is going to be fixed at a fixed location, take a small water meter, for instance, has the good coverage there, because it won't move, so the coverage will remain the same. So you need to decide at the very last stage, when the device is on the field. Here you have no choice. So that's because of your business, of your use case, and the way you handle the business. For some other cases, I would say, for instance, the smart label, I think it's much better to have this in-factory profile provisioning, because here you want to maximize the lifespan of the label, and this label is going to move by essence. That's it has been designed for this. So that's it's important to keep in mind that power savings are important. Sometimes you cannot avoid some power hungry operations, and it's because of your use case, or it's because you're going to lose the control on your device. So it's better to change the connectivity on this device, consume some battery, some energy to do that. But it's still better than sending someone to rescue the device or fix it.
Yeah.
So it's really managing, optimizing your business. There's no single answer, I think, to the questions. We cannot say it will always be like that. It really depends on the vertical market you're talking about.
Absolutely. I said we get to the questions from the audience at some point. I'm just looking down through them. Most of them we've kind of answered already. How are IoT devices being made for iSIMs? We've tackled that, I think. How is it different from eSIM? We've certainly tackled that. How can iSIMs work in a global supply chain? I guess really that's talking to the idea of remote SIM provisioning, and whenever the device appears in field, it localizes, or you can do a local SKU via or local or have a particular profile pushed to the device in the in-factory profile provisioning approach. I don't think there's really necessarily anything to add to that. Is there, gentlemen? That question of iSIMs working in a global supply chain?
Why not?
Yeah.
If you really have a global supply chain, I would assume that that use case needs eSIM. So we are talking about integrated eSIM or EUICC in that case. But then if you want to have all these benefits from an integrated technology, then this is the way to go. Why not?
Okay, one question came in, which is one that I was about to ask myself. I mentioned about this, the focus being on power consumption, or at least that's in the name of the session. There is a question about power consumption variance between iSIM being UICC or EUICC. Can we talk generally about what the sort of quantum of benefit you might get of iSIM versus eSIM or versus plastic SIM? What are we talking about?
Well, I think it's in IoT devices typically, and the basic ones, they don't communicate that often, especially to save the battery. So that means they spend a lot of time in a deep sleep mode, and this is where you can make the difference between an integrated SIM, which is inside the chipset that has very powerful power management control or solutions implemented inside, and also because the chipset is built using advanced technology nodes, meaning the way the chip is built. The size of the transistor is very small compared to what you have in a secure microcontroller typically on the market. Doesn't mean you could not do that with or have the same level of or the same advanced technology for the standalone eSIM, but the way the market is structured is that you don't have access to these chips. The foundries prefer to focus on very powerful SoCs like Snapdragon, GPU, CPUs, etc., with 5 nanometers or less, of course. That's a business reason actually, not a technology. For the core of the processor, so you gain more by going integrated. That's for sure. Then you have some limitations, because if you want to have you need memory for an iSIM. You need non-volatile memory, and this you cannot build this manufacture this memory with 5 nanometer technology. There's a physical problem there. So that means there's a limitation. Still, you cannot optimize infinitely the power consumption. So yes, you will have a gain. The gain is I would say, I cannot share detailed figures, but I think you can divide by 2 the size of the nodes when going from the eSIM or the SIM, which is the same problem, to the integrated SIM. So that's very, very interesting in IoT.
Okay.
But we see the SIM products and the eSIM products using chips are more and more advanced. So the gap is getting a little bit smaller these days, but still there's a gap that is significant.
Okay. One other topic I wanted to get onto was around security and certification. Stefan K, I wanted to come to you first on this one. You mentioned something around security certification and so on. I'll be interested to kind of unpick that in terms of the challenge in the context of the life cycle of the radio module. How would that work in terms of certification and security for the device?
Very good question. Before I come to that, I have a figure regarding the power savings for integrated
Answer the question previously. Yeah, very good.
Yeah, exactly. So according to our measures and measurements and the measurements that have been done by our partners, of course, this is implementation dependent, but we were able to detect a power saving margin of about 90% compared to a classical SIM. This does not mean that the device is going to consume 90% less. It's only the integrated SIM versus the classical SIM. Integrated is 90%, roundabout 90% less, because there is no processor to be powered, there's no memory to be powered, and so on. Yeah, depends on the use case if that makes a difference. Sometimes it does.
Sure. And on the question of security and certification.
Yeah, coming to that now. Yes, especially operators are normally very keen to understand what is going to happen to their secrets. So every SIM card contains a secret key. That secret key is to be used to authenticate the subscription or the card or the device towards the network. So that is all about network access security, and that's a vital interest of every operator. So operator need to be sure that wherever they give their credentials and where they are kept, this device is secure. How can that be proven? Of course, operators could do analysis on their part. Every integrated SIM could be analyzed to the nitty-gritty details. But the more elegant solution is that this device comes with a security certification issued by an independent certification lab. And that's typically what also is done in the eSIM context. Every eSIM has to be certified across standardized, according to standardized criteria, common criteria, EIL 4+ at least. These are the requirements. Yeah, and if that device has passed, operators can rely on that. And the same thing is also required in the iSIM context. Operators don't do the iSIMs. They have to rely on the security of these devices coming from various different other sources. And the only way of proving that is a certification. However, this costs money and also takes time. Is that compatible with the relatively short and becoming shorter and shorter life cycles of these devices? Which limits does this impose? So these devices, radio modules, have to be further developed. So if you change a particular part in there, does that avoid the certification? Sometimes it does, but then you have to go through a Delta certification and on and on and on. So actually, there's a security interest, a vital security interest, especially from operators, and then there is a life cycle interest, so to say, from the device makers. And somehow we have to find a compromise, and that's the challenge.
Good stuff. And Nadav, I want to come to you just to give you the last word on that. You've been sitting there patiently. This question around security and certification, how do you think about that at Flow Live?
So yeah, basically what Stefan said was very comprehensive, and I agree with what I say. But what we see is that the security components that result because of the iSIM. So what we've seen from our customers and the pen test that we try to do provided much greater security from our perspective. We treat it as a more robust and it really fits highly regulated areas, markets where you see that there is a need for higher security. But then again, what Stefan said, I can't agree more.
Okay, excellent. We're out of time, I'm afraid, gentlemen. I have to hand back to David now. We could go on like this for hours. Hopefully that's been interesting. There have been a few other questions that have come in. As Keith mentioned at the top of the session, the questions will get circulated around to the speakers. But back to David.
Thank you, Matt, and I'd like to thank our panelists as well as our audience for joining us today. Please join us tomorrow for 2 more tracks of our IoT Day Spring event, one on low-power IoT bringing benefits to tried and new applications, and one on IoT security and low power. Please join us for those tomorrow, and thank you all for joining us.